All right, thank you. So the quick answer to snowmelt is yes, we are. It's a really important variable. So there's been a reports of precipitous insect declines across the planet that some describe as an insect apocalypse. Uh, If that's true, it has severe consequences for other life forms, including humanity. But the question we're after is it happening in our region? And more specifically, what are the climatic impacts on phenology and plant-butterfly relationships, similar to what some of the other talks in this session have raised? What I'm going to talk about today is a complement to the Cascades Butterfly surveys that Regina mentioned. Using a single annual survey, try to be timed at peak bloom and butterfly abundance. It's been going on for about 10 years. The results are first that meadow habitats have been strongly persistent, at least qualitatively. Butterfly abundances show very high interannual variability at all spatial and taxonomic levels. And butterfly and plant phenologies are very sensitive to weather, and the impacts of climate-driven phenology shifts are still analyzing. So there's more to come. If you could go to the next slide, please. So these are a bunch of articles or titles of articles showing evidence of severe insect declines across the world. I'd like to draw your attention to the top ones about that Forrester et al. Looked at in the western states, where they found a 1.6% decline per year in butterfly abundances across these states. That adds up to an awful lot extended over multiple decades. What they looked at was the effect of climate change, of pesticides, and habitat loss in the form of mostly development. And that really points to the great value and importance of national parks, which really control for those other factors where pesticide use and development are really minimal. So we can really hone in on the impacts of climate change. The objectives I had are a number, looking at meadow status 50 years later after their original delineation, trying to work out baseline butterfly distributions, some of the determinants of those distributions, butterfly population dynamics, it's a long-term objective, and then ultimately responses to climate change. If you go on to the next, please. I started with Jim Henderson's map from the thesis he published in 1973. The rectangles on this are from a butterfly inventory we conducted in the park in 2009. But you can see the meadows of a variety of different types. You can see they're color-coded according to the legend on the right. Henderson mapped these meadows. You can see they form more or less a ring around the park that's really driven by elevation. The lower limits are 1,500 meters, or about 5,000 feet, and the upper limits are really determined by the limits of plant growth in the alpine zone. Let's see, if we go to the next slide, please. This shows my survey route in orange. Basically, what I did was to follow that ring of meadows around the park each year, following the Wonderland Trail, the Northern Loop Trail, Spray Park Trail, and then you can see a number of offshoots. And then some years I was able to spend an additional day on the Palisades Lake Trail up in the northeast and the Tatoosh Range down in the south. Essentially, what I was trying to do was to fill in the gaps from the Cascades Butterfly Project. You can see the 5 transects that Regina mentioned in yellow at various points around the park. As Regina mentioned, butterfly sampling is very weather sensitive, and so when I would get to a place, if it was raining, I could record plant phenology, but not butterfly abundances. So there are some gaps in some years in some of my sites. Next slide, please. So the meadows, at least qualitatively, have been remarkably persistent. So here I've used that same map, and the meadows that have changed type from one type to another are marked with asterisks. So you can see there are a number of purple asterisks where meadows that Henderson marked as dry grass or low herbaceous are now lush herbaceous. And so that may indicate longer growing seasons, enriched CO2, or some other factors that I'll leave to the botanists. Also up near the north, you can see a green asterisk at a meadow called Cold Basin, which has now become subalpine forest. So there's some other talks in this session about that, but I have seen some of that at Rainier. If we go to the next slide. Here's some example of what that looks like, where you have subalpine firs encroaching upon meadows. As that continues, eventually those habitats will cease to become functional habitat for most butterfly species. If we go on to the next, that tree encroachment will take place over decades. More immediate is shifts in phenology driven by changes in the timing of snowmelt. If you typically, as other people have mentioned, once the snow melts, plants start their activity. Some, like avalanche lilies, start even before the snow melt, and then they bloom and then dry out and senesce as the soil dries out. Typically, peak bloom in these meadows occurs around late July, early August, which are the images on the right. At that same time, in 2015, you have images on the left where almost all plants had senesced by the time they typically are in peak blooming. And so that's a substantial phenology shift. And the question is, when things happen 1 to 2 months earlier, what does that do to butterflies and plant butterfly phenology overlap? Go on to the next slide, please. This basically shows the same thing. On the left is a phenophase plot for American bistort. This is in Julian dates. So if you think about it, July 1st is about number 182. And so you can see that in the year 2015, bistorts had already started blooming before the end of June. And then they had started senescing, or even had finished senescing by the end of July, normally when blooming starts. So what does that do to butterflies? Well, if you look at the panels on the right, you can see that Arctic fritillary, the one in the middle, they seem to at least with peak abundance, seem to keep right up with the earlier blooming of plants. But next to it on the far right, the Mormon fritillaries, they lag far behind. And so, and then the checker spots down below or somewhere in the middle. So something like a Mormon fritillary, those butterflies are flying, they're mating, they're laying eggs, but their larvae are likely to enter a world where there's nothing left to eat. And so those larvae are likely to starve before they can reach the instar at which they can overwinter. And so that is going to manifest in substantially reduced abundances. And we would need to look at data from subsequent years. That analysis is ongoing. Go on to the next slide, please. What we can say immediately is at least forecast which kinds of species are most likely to be impacted. And so here on the left, I've got a number of characteristics. Those that feed on multiple hosts, particularly shrubs, are less likely to be impacted by phenological shifts. Strong flyers that can get to a meadow that hasn't dried out yet. And those that overwinter as adults that can emerge and be active as soon as things warm up. On the right side, you have basically the opposite set of characteristics. This isn't perfect. So on the left, you have some blues that are weak flyers, but they feed on shrubs, which is probably more important. And then similar with the fritillaries, they're very strong flyers, but they feed on violets, which are more likely to senesce early. So testing these hypotheses of vulnerability is something that we're continuing with. Next slide, please. In fact, in the interest of, let's see here. So first on the right, very high variability at all levels. This slide shows interannual variability, and I've controlled for unsuitable conditions. And so that's basically looking at the entire set of meadows. You also have, if you look at an individual meadow, you get similar variation. You get like an individual species, you get similar variation, and then shifts in phenology, also variation. Typically, to analyze population dynamics, we've seen from earlier work, takes 20 to 30 years. By working with data from multiple sites, I hope to reduce that substantially. And then finally, on the right, it looks like lush meadows in the dark circles have a much stronger relationship with abundance. You increase size a little bit, and you get a huge increase in butterfly abundance, whereas less productive sites, not nearly so much. If we could skip down to the last slide, please. The next one, please. Up, one up. So I'd like to conclude with one down below that. You never know quite what you're going to find. This past year, as I put down my pack to record some of the data, 4 of Jocelyn Atkins' wolverines that she discussed yesterday loped past me and off and down the ridge. And so this might be an advertisement for future Cascade Butterfly volunteers. To conclude, butterflies and plants are highly responsive to weather in a given year and likely therefore to climate change. Butterfly abundances are highly variable. The analyses are ongoing, so please stay tuned. And then finally, detecting responses to climate change requires effort over many years. It's worth it, and you never know what you're going to come. All right, thank you.
Make sure your mic's off, please. Do you want to wrap up, John? Sorry.
I just did. Basically, you never know what you're going to find. A wolverine might cross your path when you're out collecting data.
Thanks. Sorry for the last minute interruption. So aside from assuring all volunteers that they are going to see wolverines out there, it's a really exciting presentation, and it's really interesting to see some of that meadow stability, but the variability in butterfly response. Does anyone have any questions? We have a few minutes for questions here. Carter in the chat asks, would you change anything about the survey design if you were starting all over again? That's a tough one.
Actually, what was critical to this was Henderson's data. I also did surveys, inventory in North Cascades National Park, and we didn't have the same data, so it's really hard to work from a data set. I'd give myself more time. My good friend Roger Christofferson says you have to spend 3 days in the office for every day you spend out in the field, and I think I have a debt to pay off on that. I've been collecting data, and I have too many other things. I haven't been analyzing it enough, and so there's a backlog of data analysis. Regina and I need to get together and analyze both my data and all the Cascades Butterfly Project data. There's an awful lot here, and get together with some of the other presenters who are, all the work on meadow extent and tree encroachment and snowpack data. We have a lot to collaborate on.
Yeah, that sounds really exciting. And Tabby volunteers in the chat that the wilderness rangers at Mount Rainier love to help with surveys. So they're just putting that out.
I should put a plug in. Yeah, the Wilderness Information Center staff, particularly Sarah Pigeon and others, have been extraordinarily helpful in fitting me in, being able to get to these sites. They've actually been wonderful.
Yeah, and you've covered a lot of ground there in the Wonderland route, and it's great to see that Henderson work put together again in the context of these other indicator species, the butterflies, which I'm excited to learn a lot more about. We have time for one more question if anybody wants to jump in. Just more offer. Everybody wants you to do butterfly work there now at San Juan as well. So once you get back out of the office, you can go out in the field.
I'm working with a graduate student on San Juan. I think it's the Island Marble, trying to do analyses for them. So yes, there's lots of butterfly work to do everywhere.
That's great. Next year we can hear about that too. Well, thank you so much for your exciting talk, and we're looking forward to seeing more of your research.
Okay, thank you.